Welcome to this session on functional group. Now functional groups, they play a very important role in organic chemistry. You should be aware of the functional group and you should be able to recognize when I tell a particular functional group which class of organic compound are we dealing with, are we talking with. So here we come to the functional group. The functional groups are here. When we speak about alkane, you can see this alkane. The functional group is carbon-carbon single bond. Here, carbon-carbon single bond. When we talk about alkyne, then the functional group here, can you see this is alkyne? The functional group is carbon-carbon double bond. Here, carbon-carbon double bond. When we speak about alkyne, alkyne, then definitely the functional group has to be carbon-carbon triple bond. So alkyne will at least have one carbon-carbon triple bond. Similarly, alkene will always have, at least you will see one carbon-carbon double bond. If you cannot see a carbon-carbon double bond, then this is not an alkene. We come to the next category, that is an alkyl halide. For an alkyl halide, the functional group here is the halogen atom. Now this halogen atom, as we know, can either be chlorine or bromine or iodine or fluorine. It can be anything. We come to the next category, that is aldehydes and ketones, and they are also very important. Now both this compound contain this typical group here. Can you see this group? This group is given a name. We call it as carbonyl group. We call it as carbonyl group. Aldehydes and ketones both contain carbonyl group. Now what is the functional group here? See, the functional group here is this particular group, CHO group. Here we have labeled it CHO. For a ketone, the functional group is this group, COR. See, although you can see R dash, but we don't write it as R dash, we just write it as COR. Now what is that R? That we will see. Or what is R dash? We will see. Are they same? Are they different? We will see. Don't panic, but we say COR. But one thing is common, that both of them, they contain carbonyl group. Now if you want to see the difference, you can see the difference here. If you can see the difference here, in an aldehyde, you can see this part. Can you see RCO? The same part you can see here for a ketone. Then what is the difference? Let us take a different color so that you can understand it much better. Now here, I take a different color so that you can understand it much better. Can you see here? We have a hydrogen atom in the case of an aldehyde here. And you have an alkyl group in the case of a ketone here. That is the difference. For an aldehyde, we have hydrogen atom attached to the carbonyl group. And on the other side we have an alkyl group here, but for a ketone you can see that both the groups attached to the carbonyl group, they are alkyl group. We come to the next functional group, and the next functional group is nothing but, if you see the next functional group, the next functional group is here. Okay, what is the next functional group? The next functional group is this particular group. What is that group? This group is actually called as carboxyl group, and a compound containing carboxyl group is a carboxylic acid. So for a carboxylic acid, the functional group has to be COOH. Here, where it is here. Similarly, we have a derivative of carboxylic acid. We call it as ester, where the functional group is this group, COOR. Though we write R dash, just say it as COOR, where R or R dash is an alkyl group. We will discuss it in a short time. Now where is this functional group here? You can see it here. So what is common between these two people? The common is this part. See here, this part is common. This part is common. This particular part is common. यहाँ तक कॉमन है. फिर डिफरेंस कहाँ पे है? You can see the difference. I'll show it here. See here, यहाँ पे H है, और यहाँ पे तुमको क्या मिलेगा, R. Alkyl group, R dash, R. What are they? They are nothing but alkyl group. So now, do you understand? If a compound has this particular group, what this group, this group, this group. If a compound has this particular group, what group? Here, COOH. Then it is an acid. What type of acid? Organic. We don't say acid, we say carboxylic acid. And here, if a compound has this, I say this as the functional group, then the compound has to be an ester. We come to the next derivative. Here you can see amide. Can you see amide? Now here, amide is here. Here. This is amide. CONH2. This is the functional group. CONH2. Amide group. We have next category which you call it as amine. There is a difference. It is amide DE and this is AMINE. Amine. Amine has this as the functional group, amino group. It has this as the functional group which you call it as amino group. So you have studied carboxylic acid, you are familiar with ester, you also know what is an amide. Is it all right? Now we come to the next category. And what is the next category which we are coming to? What is the next category we are coming to? The next category which we are coming to is this category of compound, alcohol and phenol. Now what are alcohols and what are phenols? Okay. See, both contain this as the functional group. Can you see? Then why do you call this compound as alcohol? And why do we call this compound as phenol? If you carefully see here, if you just observe this here, you will understand that here the attachment is to an alkyl group. The OH is directly attached to an alkyl group, whereas here it is attached to an aromatic ring. So when the hydroxyl group is attached to an aromatic ring, then we say it is phenol. But the same hydroxyl group, when it gets attached to an alkyl group, then it becomes an alcohol. But the functional group in both the case remains the same. And what is the functional group in both the case? The functional group in both the case is nothing but hydroxyl group. But what is the difference? The difference is here. One is attached to alkyl group in the case of an alcohol, and in the case of a phenol, it is attached to an aromatic ring. We come to the next category. Now what is the next category? The next category is here. We have nitrile. Can you see nitrile group here? Here. Cyanide group, CN. Here. So nitrile has a functional group CN. How do you write CN? It is C triple bond N. Please remember, the valency of carbon atom in any organic compound has to be 4. Can you see where is the valency 4 here? Here I'll show you with arrow. You can see here. See, I'm talking about this carbon. So here these are the valencies here. Can you see the cursor? So nitrogen valence is 3. So this valence is common both for nitrogen atom as well as for carbon atom. So 3 here and 1 here on the left hand side of this carbon left. Okay. So 4. Remember this basics. We come to the next category, nitro compounds. A nitro compound, you can see that the functional group is nothing but a nitro group. The functional group is nothing but a nitro group. We have one more category which you call it as ethers. Now in ether you can see the functional group is here. See, oxygen which is divalent. So on one side you have an alkyl group. We have got an alkyl group on one side. Where is the alkyl group? Here. And where is the second alkyl group? Here. So R dash can be similar or they can be different. Sometimes you have both the alkyl groups which are similar, they may be different, or you may have one alkyl group and one aromatic ring, or both aromatic ring. There are a lot of possibilities. We are not going into the detail as we are studying the functional group. So functional group is this group O, attached to alkyl group or aromatic ring. Now in this entire session, have you seen that I was repeatedly talking, I was repeatedly telling you R, R dash. What are all this? So please understand this and try to mug up this reactions, not reactions but this group. So we have R, R is nothing but R is an alkyl group. Now here, this alkyl group, can you see here? This is your alkyl group. Alkyl group. So we have R ka value as CH3, methyl group. See, in a methyl group, we have one carbon, 3 hydrogen atom, but carbon valency has to be 4. So you have a bond here. Can you see this? This is a free valency through which it will get attached. A methyl group is written like this. So by heart, when I say one carbon atom and 3 hydrogen atom, immediately you have to understand it is methyl group, and it is through this particular valency, free valency, it will get attached. We have another group which you call it as ethyl group. Total number of carbon atom here you can see is 2C2H5. Can you see this? I am talking about this group now, this. We are talking about which group now? We are talking about this group. Here, I am talking about this group. What group I am talking about? This. Okay. See, I am talking about this group. So understand, we are talking about this group. If we count the number of carbon atom, it will come out to be 2. Hydrogen atom will come out to be 5. Is it all right? So can you see there is a free valency here. There is a free valency here. It is through this free valency it will get attached. Right now just remember, ethyl group has 2 carbon and 5 hydrogen atom. We come to the next group. The next group is nothing but a propyl group, and a propyl group looks something like this. A propyl group will look like this. Total number of hydrogen atom and total number of carbon atom, let us count. Carbon 3, hydrogen atom 7. Then this group down, this is also propyl group. There is a difference in name, no? This is what we call it as N-propyl and this is what we call it as isopropyl. So यहाँ पे carbon atom 1, you can see that the attachment will be through carbon atom 1, but here the attachment will be through carbon atom 2. So isopropyl. यहाँ पे carbon atom 1 where the cursor is, valency is not fully satisfied. Can you see this? This part, this part, very important, this part. Which part? This part. So let me remove this. It will get attached through here, carbon atom 1. यहाँ पे it will get attached through carbon atom 2. Why? Because if you check carbon atom 1, the valency there is 2 hydrogen atom, 1 with the carbon 3 and 1 valence is not satisfied. So that's the reason why they have put it like this. See, I'm showing you again. फ्री वैलेंसी कहाँ पे है? कार्बन एटम 1, और यहाँ पे फ्री वैलेंसी तुमको कहाँ पे दिखाई देगा? कार्बन एटम 2. But if you talk about number of carbon and hydrogen atom, they will remain the same. 3 carbon, 7 hydrogen atom. Then what's the difference? N-propyl attachment will be carbon atom 1. Isopropyl, the attachment will be through carbon atom 2. Then we have another one which we were talking about, and that is nothing but aromatic ring, AR. You have seen AR, na? In the earlier somewhere we have used AR, phenols. You remember? Phenol, where the OH group is directly attached to the aromatic ring, And the simplest of the aromatic ring which you can have is this compound, the parent compound, parent aromatic compound. Simplest of the aromatic rings which you can think about is benzene. So try to study this, write it, practice it, and see that it is in your memory. So methyl group, it is 1 carbon 3 hydrogen atom. This is methyl. If you talk about ethyl, you have 2 carbon atom and 5 hydrogen atom. If you talk about propyl, you have 3 carbon, 7 hydrogen atom. But when it comes to propyl, it can be N-propyl or isopropyl. N means point of attachment will be through carbon atom 1. Why like this? Because you can see this, ये bond है ना, ये शेंडी जिसको मैं बोलती हूँ, this bond is here on carbon atom 1 and यहाँ पे तुम्हारा जो free valency है वो carbon atom 2 पे है. So जो free valency यहाँ पे carbon 2 पे है तो it becomes isopropyl. Ar is nothing but aromatic ring, and the simplest of the aromatic ring which we can have is benzene ring. I hope you understand this nicely. You can go through this video a number of times so that you practice it and you become conversant with the functional group. You easily understand that carbon-carbon double bond functional group is the functional group. Then you are talking about an alkene. Triple bond carbon-carbon triple bond is alkyne, like this. Aldehyde CHO, ketone COR, carboxylic acid COOH. For an ester it is COOR, like this. You should know it by heart. For an amide is CONH2. For an amine NH2. Then OH, if it is a functional group, then that depends whether it is attached to R, call it as alcohol, and if it is attached to aromatic ring, then call it as phenol. For a nitro compound, NO2. For a nitrile, CN, ether O, like this. Is it okay? Now please practice it till we meet in the second video, because if you don't know this functional group, it becomes very difficult to teach you organic chemistry. There are few things which you must know. You have to know this. Once you know this, it becomes very interesting and easy to understand the topic. So write it and practice it. Thank you and take good care of yourself. Till we meet in the second video.